is talking about the fundamentals of machine learning, which is about logistic regression, naive Bayes, support vector machine. Clustering is the, this is unsupervised learning. Okay, some basic time series forecasting. Okay. And which will be more relevant in your context is not there. And also something like big data. Do you have a separate course on big data?
Uh, it's not in the
Do you have
curriculum.
a separate course?
Not in the curriculum.
Okay, so I think
Not.
that's yeah. So I think that is again something that probably as practitioners you must know, because most of the data that you will be working with or you are working with are uh, will be big data. Okay, because these are all machine generated data, so they typically would be big data. So that's why basic concept of big data is important. Also, what is not there is how do these models work in a cloud environment. I think last session we were talking about, some of you working on Azure, etc. So that's a very important thing because in real industrial applications, you will not be working on, let's say, a collab notebook or stuff like that because, I mean, you may have a collab notebook, but it may be hosted in the cloud because the amount of data that you require to process is much bigger. So a basic understanding of how the cloud environment works or how you apply or you deploy machine learning models in the cloud environment, I think is also very important. So that is also something that I plan to give you some exposure. So as far as the evaluation components are concerned, the mid-sem and exam, that's the normal stuff. In the one component, it will be a hands-on activity. There that we will have a strong hands-on component. On outline, there may not be much about activity. For example, we don't see much. Okay, I think you really need to know how it is happening rather than the theory of it, the mathematics of it. Because you guys, I mean, you guys are not, you will not be researching labs and in Google or in these kind of companies who are coming up. Your job so understanding of the fundamentals and how to apply that in your work context, that is more important. So that's why the assignment that you're going to have will be a one which will be hands-on. It will be one assignment and it will be a group assignment. Okay, so this I will give the assignment somewhere in the middle of the course where you have progressed a little bit, and this is where we if you can work with some of your own data, I will appreciate that. Otherwise, I will give you the usual data that is available in Kaggle, but that may not be related to your industry. So that's where if you bring your own data and if you can work on it, I think that will make more sense in the assignment. And also, we know that this program is work integrated programs. The whole idea is how to apply in your workplace rather than classical MBA. So this is the overall structure, and as I said, where I will probably kind of deviate a little bit from the structure or enhance a little bit from the structure, keeping in mind the relevance of this course for in your context. Okay. So any questions you have on this outline or any suggestions you may come up, or anything specifically you want to learn, and if I have some expertise or knowledge in that area, I'll definitely try to help. So anything specifically you want to learn, which probably is not there in the course outline, that also you could mention. So
So
in,
nothing specific.
sorry.
Go ahead. Okay, I'll do it first. Nothing specific to the course outline, and thanks very much for this info. Uh, could you also throw some light on the textbooks or documents which we have to probably um, buy?
Your voice broke in between, Prashant, if you can just.
Okay, any hints on the books which we need to purchase?
Oh, yeah, yeah, there is this. So this is, I think, a pretty standard textbook, and it is a PDF version is also available, so you can easily download that. Okay.
Okay,
Uh,
yes, sir.
yeah, yeah. But as I said, I mean, focus probably. I mean, you can use this textbook more as a reference. I mean, in the sense that I will not go chapter by chapter of the textbook. Okay, because that normally what happens, the textbooks again tend to be very theoretical. It's more for your reference, not exactly meant to be studied chapter by chapter. So wherever you think that certain theoretical constructs need to be brushed up or understood, you can refer to this textbook. Okay. Any other thoughts, questions? Great. So back to the present just started as an introductory. By the way, has everybody been able to download NIME? I think you mentioned it is available in your something. Uh, mm, we will primarily work on two platforms. One is NIME, the other is Collab Notebook. And as is for understanding of the models and building the prototype of the models. But as I said, that in most enterprises, the actual models need to be built and cloud environment because of the amount of data that is there. And we will have a very brief exposure of Azure. Okay. Let me see if we have time, then probably we'll also. Are you using Azure or AWS in your? I think even the last somebody mentioned last. What is your enterprise cloud? Which product you're using? Very aware of it.
Azure Cloud is what we are using. Professor, your voice is breaking a little
Azure.
bit. Maybe
Uh,
There's
okay.
continuous disturbances there.
The network seems to be okay. Maybe better. Okay. Okay. So I will just pull up the presentation which we're looking at in the last session and clarify certain concepts before we get into the hands-on. Okay. Yeah, I think we were here and we were talking about the characteristics of big data. Now, a question to you is: we are all heard about this term big data so often. Uh, what exactly is big data? Anybody? How do we define a big data?
I think it's a large volume.
Sorry, did I lose you?
Maybe big data is extremely
Yes.
and complex data sets. Maybe the conventional processing tools cannot efficiently process.
Vignesh, I mean, you are very, very close. Okay. So it is not about how large the data set is. It is to do with the largeness of the data set, the complexity of the data set, etc. But the formal definition of big data is that kind of data that cannot be stored or processed by conventional means. Okay, so that is the definition of big data. Okay. Now, obviously, when we say that big data is that data that cannot be stored or processed by conventional means, the question comes as to what is the conventional means? What is the conventional method of storing on and processing a data? Anybody can throw some light on that?
Storing in a local hard disk.
Not really. I mean, servers have been there for quite some time, right? So if we say storing in a local hard disk is a conventional storage, then whenever we have servers, we will call that as a big data. Okay, so probably not. Any other thoughts? Yes, anybody? Heman probably was saying something. No. Okay, so let's understand this. So two concepts is very important to understand for all of us before we proceed in actual machine learning. One is the concept of big data. The other is the concept of unstructured data, because these two terms are often misunderstood. Okay, so let us first, and we'll try to demystify these two terms, and then we will move into the various machine learning models. Okay, so let us first understand what is big data, and in that context, let us understand what is meant by conventional storing or computing in a by conventional means. Okay, so let me just draw something. I will take the example of compute, okay? But the concept applies equally well or is relevant also for storage. So this concept is applicable both for storage and compute. Let's say, and I'm giving the example of our own laptops. Let's say we have purchased a laptop which is having a 4 GB RAM. So initially, whatever work that we have been doing is sufficient for this 4 GB RAM. Okay. But gradually, the volume as well as the type of the work increases, and 4G we find 4 GB RAM is not sufficient anymore. Okay. What do we typically do?
We add additional RAM if possible.
We add, so I'm not getting into the situation where you'll probably throw away this 4 GB laptop and buy a new 8 GB laptop. Why? Because in real scenario, when we talk about enterprise grade investments, there is a sunk cost of this investment. So it is not easy to throw away the entire thing and buy a new one. And also there is another important reason why this may not be a very scalable option, which I'll come to that later. So most of the cases in such situation, if we don't throw away the laptop and buy a new 8 GB laptop, we'll probably add another 4 GB RAM in an extra slot that has been provided in the laptop. Most of the laptops provide extra slots to augment the RAM or even augment the storage in terms of hard disk, etc. And this way, maybe as we increase further, the workload increases, we then have another, let's say, 8 GB RAM. So this method, where we are trying to increase the compute or the storage capacity of a single machine, is called scaling up. So in the enterprise scenario, the same thing happens, except the fact that instead of a laptop, probably it's a server. And instead of 4 GB, this may be some 32 GB or something like that. And it will, you tend to augment it both in terms of storage and compute, and it goes on. Now, my question to you is, can it go on forever? That means, is this scaling up, can this scaling up be infinite?
There might be limitation with respect to data exchange between the processor and the storage.
Not only that, there can be limitations in the physical hardware itself. So let's say I have a laptop and I have only one slot where I can augment 4 GB with another 4 GB. Okay, I cannot do it beyond that, because first of all, I may not have slots to do that. Second is, even if I have slots, there are various other parts of the machine. For example, let's say the heating system of my laptop, it will not be, it is not designed to, let's say, take total the computing load of 16 GB. The heat generated will be much more when my laptop will conk out. So there is a ceiling to the amount of storage and compute I can do on a single machine. Now, over the period of time, all the server manufacturers of the world, the IBMs of the world, etc., okay, IBM, Compaq, etc., their objective was to bring in more and more powerful servers, so that in the single server, you can add more and more data and you can add more and more compute. Till the primary data in organization was transactional data. Okay, we were talking about the various kinds of data in organization, I think. So for if you look at two main data streams that are there in organizations, I'm not sure whether I have discussed this. I think I mentioned this very briefly, but it's important to just, I'm digressing a little bit just to give this important aspect, that in any organization, there are two major streams of data. Okay, one is the IT stream and the other is the OT stream. IT, I'm sure all of you know. Is everybody aware of OT? The full form of OT? Yes, no?
I'm not aware. Yeah.
Okay, it's operational technology. So IT is information technology. So this is where your sales, your purchase, your accounting, okay, all this information will lie. Okay. This is from where we, as managers, we take out reports, we analyze the data. So this is entirely information technology, IT. OT is where machines exchange data. For example, temperature, basically sensor data. So if I look at, let's say, industry 3.0 scenario, each of these machines were first the PLCs came in, where each of these machines had sensors and had logic controllers based on which we could control the machines. And then there were protocols that were developed that machines could talk to each other. So one machine will talk to each other. Okay, that's the OT. But interestingly, there was no communication between IT and OT. So if I have to, let's say, record how many units I have sold, okay, what will I do? There will be an operator who will count the number of products to be sold and then enter it into the ERP system manually. Or let's say I want to track what has been the, let's say, the downtime of a machine. Somebody will get the data from the OT system or even manually track it and enter it into the ERP system. So there was no automatic flow of information to and fro of information between the IT and the OT layers. Industry 4.0 actually enabled this communication, okay, because this communication needed the cloud in between. For the IT and the OT to talk to each other. Okay, so that was what was happening. So till the time I did not have the OT information into my business decision making. In terms of manufacturing, my data was not very large. My data was primarily the IT data, which is a transactional data. Even for a very large organization, the number of sales or number of purchase or number of vouchers that are being entered is nothing compared to, let's say, the number of data points that you are getting from the turbines of a Boeing engine. Okay, or let's say telecom data. So till the data was transactional data, people could manage with these high-end servers. So essentially, IBMs of the world were making money by making very huge servers who had a huge compute and huge storage in one machine. And companies are okay with that because it was possible to manage the transactional data with this method. However, the problem happened when the data started coming from various other sources. One of the sources, as I mentioned, is the sources from this OT data. Okay. So now if I want to have this OT data, the sensor data, the temperature data or vibration data, and I want to take this data and build a model to say that, can I use this temperature or vibration data to predict whether a machine is going to fail or not? I need to have a communication between my OT and IT layer, because the building of the model that will predict whether the machine is going to fail or not will happen in the IT layer, whereas the OT layer will give the data about the sensors. So a seamless integration between these two layers are required. And a further challenge is that if the information is two-way, that means if I just take the data and just want to get information about whether the machine is going to fail or not, that's one thing. It's a more complex thing to say that, okay, the IT layer will pass on the information. If the machine is likely to fail, stop the machine. It has to pass on a command that will stop the machine. So that means my information has to be to and fro, and my information has to be real time. Okay. So the amount of data that I need to process, the amount of compute that I need to do is far more complex. So this model is not going to work. I need a model that can be infinitely scalable. I should not have this ceiling that beyond this I cannot scale. So what do I need? I now need machine where I have a 4 GB machine, and then I have, when I need, I can make another 4 GB machine. When I need, I can make third 4 GB machine, and I can go on forever. This is called scaling out. So if I go by this definition that big data is that data that cannot be stored or processed in conventional means, this is the first criteria of a non-conventional means. That means instead of scaling up, I should be able to scale out. Okay, so far fine, everybody?
Yes.
Okay. Now, scaling out has some challenges, especially with respect to compute. Okay. Now, what happens when you scale out is a huge bunch of data. Let's say I have 1 million or let's say 100 million records. So this data has 100 million records. Now this 100 million records is now getting divided like this 10 million, 10 million, 10 million. So imagine that you have a huge Excel file, and this Excel file, one Excel file, the data of this one Excel file is now not in one file, but in 5 files. Okay. You may say that what's the big deal? We do it all the time. That, different departments have their different, let's say, different departments have their own employee records. I'm just taking a simple example that every department keeps their employee record in one Excel file. And somebody says that, okay, I need to calculate what is the average salary or what is the total salary of all the employees. So, of course, it's not done like that in an ERP system. It will not be done like that. But just to take an example, that let's assume that all the employee salaries of the month are kept in different Excel files in different departments. And the management wants to know that this month, how much salary did I pay to all the employees? So we said that's not a big deal because all the departments will send their Excel files to one department, let's say the HR department. The HR department will merge all the files, copy paste all the files, and do a sum and find out what is the total employee expense. Now this assumes that one laptop where all the 10, let's say there are 10 departments and 10 departments Excel files were merged, that one laptop has the capacity to save an Excel file which has data from all the departments. But this fundamental assumption is not valid here because we want to scale out, or we are scaling out in the assumption or with the assumption that is not possible to perform a compute or storage on one single machine. If we could do it, then scaling up was okay. So which will be that one machine where I will combine all the data and do the compute to find out the total salary. Okay. So the entire process of storage and compute needs to change. Now, how this needs to change? In order to understand this, we will have a very simple analogy. The simple analogy is, let's say, how election happens. Okay, and let's take 2 countries. Till now, everybody fine? Any questions, thoughts?
Fine.
All good? Okay, great.
Yeah.
So, let's take the analogy of election of 2 countries, India and Switzerland. Okay, again, I'm taking a hypothetical example. We know how election happens in India, but we are not very sure how elections happen in Switzerland, but I'm just assuming. So Switzerland is a small country, both in terms of population and area. So I am presuming that in Switzerland, let's say if election happens, there can be an election office here. Okay. Election commissioner is sitting, and we can ask everybody to come to this office and cast their vote once in whatever 3 years and 5 years. Correct? So this is possible when the country is small and the number of people are less. But can I implement this in India? That we ask that everybody in India, next election, they have to come to Delhi. Whichever part of India you are in, you have to come to Delhi and you have to vote. Obviously, it's not a feasible solution, correct? So what we do in India? India, we have different election booths. These are election booths. Each election booth is located near a group of people. So these group of people come to the election booth and vote. So if you go by this olden days, the way elections used to happen, nowadays also it happens like that. Instead of that paper vote, you have the election, this electronic voting machine. But essentially, all these, even today also, I think the election voting machines are brought to a central place. Once the vote has been cast, it is brought to a central place, and then the summation of all the votes happen. So this is a two-step process. In the first step, you are getting votes from people, and the votes are taken at a place which is located near the people. Then you are aggregating them in a separate place. Okay. Now, compare this with what happens in computers. In computers, there are two layers. One is the application layer, and the other is the database layer. There is a third layer called user interface. So it is basically used for interacting, the user interacting with the application layer. Okay, but this one is not important for this particular discussion. So let's say when we ask Excel to do a sum, what is actually happening? The data is stored in the database layer, which is actually the persistent storage. Okay. Excel is not exactly a database. Excel is a file system, but for the time being, if we ignore the difference, assume that data is stored in the Excel, in the database, which is a persistent system. Persistent system means it will remain forever. It is not temporary. When we are asking or calling or asking the data to do a sum, what actually happens, because the sum is an application, you are doing a calculation. Calculation cannot happen in the database layer, because the structure of the computer to store data and the structure of the computer to compute the data, these are kind of, you can say, these are trade-off. Any computing unit that is meant for storing will be weak in computing, and any computing unit that is strong in compute will be weak in storage. Okay, that's a constant trade-off you have to play. That's why you have two layers internally. Even in a laptop, we have two layers, okay, RAM and ROM. So what happens when we actually want to do the calculation? The application layer calls the database layer and brings the data temporarily into the application layer and does the calculation. Once the calculation is over, it erases the data in the application layer, because the application layer cannot store the data persistently. So erases the data in the application layer. Okay. Again, next time you want to do some calculation, it will again call from the database layer and do the calculation and erase the data. So here, what happens essentially, it's very similar to this Switzerland model, where if you consider the data to be people, the people will go to the election commissioner's office, cast a vote and come back. So here the people are going to the central body where this casting of the vote and the calculation is happening, and once the job is done, coming back. So in a classical system, data moves to compute. Is this clear? Is this analogy understood? Yes, no? All good?
Sir, can you please explain the data movement? What you explained?
Yes, sure, no problem. So again, I'm not going into the actual technicalities of it. That's a subject of computer science. I'm just trying to explain this in the form of an analogy. What is the analogy? In a small country like Switzerland, where the area is less and the people are less, people will go to one central place to vote and come back. Similarly, consider the central place as the application layer in the computer. The application layer does the compute. And because it does the compute, it cannot store. Okay. And similarly, the database layer keeps the data, stores the data, but it can't do compute. It's like, it's a trade-off. The database layer cannot do the compute and the application layer cannot store the data. Why? Because that's how, computers are designed. Okay. No computer can have, or no part of the computer can have, both these properties together. So even in our computer also, there is separate application layer, there is separate database layer. So if I have to do a calculation, typically in a normal scenario, the application layer will call the data from the database layer. I want to do a simple perform a sum. So it will take the data from the database layer, perform the sum on the application layer, because now it has the entire data in the application layer temporarily, but it cannot keep it stored there forever. Once the calculation is done, once the voting is done, the temporary data in the application layer will be erased. Next time
Understood.
again, next time you
Yeah,
again are asked to do the calculation, again it will call the data from the database layer. Okay, so
Yeah, it
essentially
is just like RAM and ROM in
RAM
a
and ROM,
computer,
right?
right? Yes,
RAM and
yes.
ROM.
Okay.
That's
Yeah,
exactly
yeah,
what it is.
understood.
Okay, so what is happening over here is the data is moving to the compute. So you can consider data to be equivalent to people, and compute to be equivalent to the election commissioner or election system. So in Switzerland, the people are going to the election system and voting and coming back. But look at what is happening for India. India, you still have the election, but it is divided into two stages. First, there are small election booths or offices where people are coming and voting. So that means this application is now getting distributed. Okay, this application is getting distributed, and it is first doing the calculation or doing the calculations and in a local environment, or rather distributed environment, and then aggregating the calculations. So if you have to find out the average temperature, I'll first find out that average temperature for individual data sets, and then do an overall average. So here what is happening is the compute moves to data. So what is happening, this application layer is now created within the database layer itself. There is a small application layer itself. Okay. And that will do the calculation for this database and send it back to the main application layer, the Central Election Commission, where there are many other databases like this who will provide this information, and the overall computation or aggregation will happen in the main application layer. Just imagine, and once that is done on this application, so this application layer is sitting in the database layer, doing the calculation. Once the calculation is over, it is being erased. Think of it like this. Again, if you take the election commission analogy, when you have the election booths, there is no permanent structure for the election booths, right? Because election is happening once in 5 years. So there's no need on having permanent structure. So what they do, they will take temporarily, let's say schools or colleges or certain other type of such establishment, conduct the election, and once that is over, it will become school again. So the application will happen temporarily in the database layer. Moment the application is over, it will be again turned back to the database layer. Till the time application is running, it cannot store, I mean, it cannot store additional data. It will stop, it will pause the data accumulation, allow the application to do the calculation, and then come back and start storing the data by the time the application is completed. Is this clear? Does it make sense?
Sir, just out of curiosity, is
Yes.
this something similar to extendable RAM what we get in our recent phones where
No.
our
Extendable.
storage?
No. Extendable RAM is scaling up. Extendable RAM is nothing but scaling up. In the same computer, you are having many more additional RAM. That's it.
No, where our storage will be used as RAM partial. Uh,
Uh, Sometimes you do that. Yes, sometimes you do that, but it's not exactly the same. I'll tell you the reason, the way it works. There is little more complication to this. What you are saying is that the storage can be used partly as a RAM in certain
Yes.
circumstances, but this is something that one is not in scale. Okay, this one is more in scale. Okay, and we'll see that
okay.
how why what are the other complexities over here. Okay,
Mhm.
so if we come back here, what we are saying here is that so this is, let's say, these are different servers and these are distributed storage units. So this is called distributed file system, DFS. Okay, that means as and when more data is coming, I will keep on adding more and more distributed file systems. Okay. So this way I will keep on going. Okay. Now let's say there's a requirement for a compute. Okay. Let's say I want to find out. So this way all the temperature data is getting stored. As and when more temperature data is getting is coming, you are spinning off more and more distributed file systems. Now there's a need to calculate something. Let's assume I want to know what is the maximum temperature in the last 6 months. Now, the reason that I mentioned that I cannot combine all of these data into one place and then do the calculation. Okay. Data cannot move to compute. This is not possible anymore. It was possible if the data was small, but now it is not possible. So what do I have to do? We have to follow the India election model, where each of these distributed file system will temporarily allot a space for compute. Temporarily allot a space for compute, like a school is temporarily giving space to conduct the election. When the compute is going on, obviously accumulation of data will stop or it will be minimized because the resources of the computer is taken up for compute and it cannot be used for storing right now. Storing means in storing also you need to read, write, and all those things, right? So those things cannot be done. Once this compute is over, these are the local election booths. This has to be, the information has to be sent to a central place. Where the final calculations will happen. And then the central place will announce the result, in this case, announce the maximum temperature. So in this scenario, I cannot have the compute moving, data moving to the compute. I have to have the compute moving to the data. Why? because in each of these layers, which is meant to store data, temporarily I have spun off compute engines. Clear? Everybody, yes or no?
So one question, this 4
Yes.
GB, what DFS you're telling,
Uh,
in that, will there be any pre-allocated allocation, already predefined allocation where it will use for compute, or
no, this will
if
be
and when
dynamic.
required?
No,
Okay.
this is dynamic. Okay, and the good question will come to the how is the dynamic allocation happen? Because it has to that the analogy is what I mentioned. You have a school, and you have to change it to for 2 days. It has to be used for election office. So what happens? There has to be some people who have to be deployed from people from the election commission will come and they will inspect. They will change it to a place, temporary place where elections can happen. Once the election is done, they will pack their bags and pack all the EVMs and all, and it will come back to the school. Exactly the same thing, but there has to be a process, or there has to be somebody has to manage this switchover. Temporary switchover to election booth and then switching back to the original school. So here also temporarily they switch over to a compute engine and switching back to a database or a data distributed file system. This has to be controlled by some agent. Correct. It cannot be controlled by any human. Okay, there has to be some algorithms or agents that are controlling this. So who is doing all of this? Okay. Now, this particular distributed file system, the first, you can say the environment, or rather the architecture that brought this entire concept. Okay, first time was Hadoop. You might have heard this name, Hadoop.
Yeah.
Okay. They were kind of, it's an open source architecture. So they were kind of first to propose this kind of architecture to handle such large data, which cannot be handled by scaling up. So that's the reason I was mentioning that it is little more complicated than extendable RAM, because you have to allow all of these processes to work, that it has to switch over from compute to storage temporarily, okay, dynamically. Then the data, whatever you have done the compute, it has to go to a central place where the overall compute can happen. Okay. So that entire ecosystem was first implemented in Hadoop. And this distributed file system in Hadoop is called Hadoop Distributed File System, HDFS. Now there are many other distributed file systems. Okay, this is not the only distributed file system, but Hadoop first brought this entire concept of computing in this way, and this file system was Hadoop Distributed File System. And this whole process of first computing in a local environment and then aggregating it, the election process. The entire process is called MapReduce. It has two parts. One is the map part, which happens over here, and the other is a reduce part, which happens over here. Now, why they're called map and reduce, I'm again not going into that, because that's where, how exactly the computation happens and how the algorithm works come in. So you can ignore that for the time being, but this is what is called, so many times you'll hear this term Hadoop map reduce. So essentially Hadoop is the entire ecosystem, okay, or this environment, or this concept, which consists of one element, which is a distributed file system, is a Hadoop distributed file system. Second element is MapReduce, which essentially does two things: the map, which basically are distributed computing, and reduce, which is the centralized computing to aggregate the distributed computing. The whole concept works on the compute moves to data rather than data moving to compute. And there's a third component, See, as I mentioned, that there is a lot of orchestration that is required. When will this machine switch from storage to compute? Okay, and that's where it's different from extendable RAM, where is a permanent phenomenon. Here, what we're saying is that for a small period of time, it will be used for compute. Till that time, my storage will be compromised in the sense that will not have additional storage. So the data is constantly flowing, remember. Okay, sensor data, etc., is constantly flowing. So what is going to happen? Somebody has to, let's say this element, this unit is using the compute. So this, I cannot lose the sensor data. The sensor data loss means lost forever, right? So this sensor data needs to be diverted to another storage unit, which is not using the compute at that point of time. Okay, so all these things have to be orchestrated. And this orchestration is done by another element called yarn. The full form of yarn is yet another resource negotiator. Very interesting name. Yeah. Okay. So yarn is doing all of this orchestration. So the Hadoop ecosystem primarily consists of three elements: HDFS, Hadoop Distributed File System; MapReduce, which is basically a distributed computing; and yarn, which is the orchestration engine. There are many other elements, but these are the major elements. Okay. Conceptually, is this clear?
Yeah.
Yes,
Hello.
so one
Yes.
clarification.
Yes.
Finally, where does the main data get stored? In the central MapReduce or at the
No.
HDFS?
No. Main data means what? Main data means the,
Suppose,
let's
for
say,
example,
temperature data, right?
Yeah.
Okay, temperature data will be stored in HDFS. MapReduce is finding out a computation max temperature. MapReduce cannot store anything. It's a compute engine. Now, max temperature, I may decide to store in some other, I may decide to store in the IT system, some other system. It will pass on the data to that system. It will not be this system, because these systems are storing the actual temperatures. So max temperature for a particular period, I may take it to a, let's say, a data lake, which I may use it for building a model. Once that data is passed on, the MapReduce's job is over. It will start some other calculation.
okay.
MapReduce is not a storage unit. Storage unit is only this HDFS.
So it may store in HDFS, or there may be a separate IT resource storing server. It will get stored there.
It will usually not be stored in HDFS, because this data doesn't require the scaling out. This is not a big data. This max temperature data is not a big data.
Okay.
So I don't really need to store in HDFS.
Okay. So the final outcome output will be stored maybe at a separate IT layer.
So it can be a normal this kind of a database.
Okay.
Because there I don't need a distributed file system. Okay, makes sense.
Yes, sir.
Any other question? Great.
Sir, you made a statement that instead of data going to computer, computer goes to data. Can you explain that?
Yes. So here, if you see that this particular layer is meant to store data. Okay. Normally, when you are doing a computation, this data will be taken into the application layer. This data will go to the application layer, and the computation will happen there. Okay. And once the computation is done, it will be erased. But this process is inefficient if you have this kind of distributed file system. So there you have to switch a part of your data layer into an application layer, do the application, do the calculations, do the compute, and switch it back to a data layer. But then I need to do some aggregations because this is a distributed file system. I will not get the entire information from one file. Because let's say if I want to know the maximum temperature, I will get the maximum temperature of this file. I'll get the maximum temperature of this file, and then somewhere I have to combine all of this and find out what is the overall maximum temperature. Where will I do that? I cannot do that in any one of these. Because it is not meant for doing that. Okay. And this may require much more computation. This has to quickly switch back to a data layer. So it has to be sent to some other environment where only the calculation will happen. So when I say the compute goes to data, it means that you have individual compute units temporarily set up within the data layers. Once the job is done, these compute units goes back to the data units. Okay. Make sense?
Yes, sir. Clear.
Great. Okay. Now, these were the initial days of Hadoop. While it could handle the basic data processing like
Sir, one more
Yeah.
query. Sir,
Yeah,
one more
sure.
query. Can we also say this thing in terms of the RAM and ROM? Parallel analogy can we draw over here?
RAM and ROM is equivalent to application layer and compute database layer.
Yeah. Okay.
That is true. That is true for anything. Here also you have
Hmm.
RAM and ROM. Here also you have RAM and ROM. But here the point is that this is all temporary. The switching of the compute and the data is temporary in this space. It cannot be permanent. But here it's permanent. Here you have a permanent ROM layer, you have a permanent RAM layer. Okay. But here it cannot be done. That's why you need a yarn to do the switching. Okay.
Understood.
Okay. So any other thoughts, questions? Great. So so Hadoop was the first kind of, you can say, the ecosystem to handle this kind of large data. And now we know that why we are calling this large data the big data, because so I will call something as a big data only when you have this kind of an environment or a distributed file system, something like a MapReduce and something like a yarn. When you have this method of storing and computing the data, then only I will call this data as a big data. So just because the data is X terabyte, I cannot say it's a big data. Okay. Now, at the initial days, this was good enough. Things like average temperature, maximum temperature, huge amount of data, we could do some simple calculations. But very soon, we wanted to use this data for doing many more things, like predicting whether the machine is going to fail or not. What do I need when I have to do this prediction? I need various models. I need a library of models. I need to do calculations on real time, let's say, if I want to say whether the machine is going to fail and accordingly stop the machine. Now, the Hadoop ecosystem, while it can handle large volumes of data in this way, it cannot handle things like using machine learning models or processing real-time data, etc. So very soon, Hadoop was kind of another new system came up, which is called the Spark. Spark had the capability to handle this sophisticated computation. It's not just about aggregation. It is about building machine learning models. It's about real time, etc. So that Spark can handle, Hadoop cannot. Okay. So the organizations which are now handling big data for the purpose of machine learning, purpose of predictive analytics, most of the cases they have to implement Spark, not Hadoop. Is Hadoop not used at all? No, Hadoop has also evolved over a period of time. It has brought in a lot of components that help to analyze, but it is inherently not meant to analyze this large, real-time data or these models. So those some of the companies, they still have legacy Hadoop system, which they are continuing, but most of them have migrated to Spark. Okay. However, Spark has one limitation. Spark does not have a persistent storage. So Spark does not have a persistent storage in its ecosystem. So many times Spark comes with or has to work with a distributed file system, including a Hadoop distributed file system. So I can have a Spark for my computational purpose, for my models, but my distributed file system may still be Hadoop. These days, of course, all these cloud environments, AWS, Azure, they have their own distributed file system. I can work with that. But the important thing is Spark is very good at compute, but it doesn't have any persistent storage. So Spark has to work with a third-party persistent storage system. Yeah, makes sense?
Sir, if you can just repeat once again in terms of with the example of like AWS and then these kind of services. So how means how this architecture is? Because this complete Hadoop system is like the AWS, or only the HDFS part is the AWS in this?
No. AWS has everything. AWS or Azure will have everything. AWS will also have a Hadoop.
Okay.
Okay, or Azure also will have it. It is your choice to configure. It's like a marketplace. Okay, it's like a marketplace of multiple technologies. Some homegrown by AWS, like let's say a simple storage system, okay, which is a kind of a data lake, or let's say something like a SageMaker, which is a platform for building machine learning models. Or okay, so these are AWS own product. It will also have Spark. It will also have Hadoop. Okay, so when you are building an entire ecosystem, or let's say an environment to build a model that will predict your machine failure, you need all of these components. Okay, and we'll see some examples and see how this works. Okay, actually hands-on.
Okay.
Okay, so essentially there what we're doing, we need to have a data lake. We need to have a distributed file system. We need to have Spark. We need to have, if required, some Hadoop also, certain places. All of these things we require. Okay. And we had to configure AWS to provide all of this. It's like a platform where all of these things are available. We have to configure it and make it ready for our the work that we intend to do. Okay. And many of these configurations today has become largely automated. So it's very easy. Sometimes what happens is that you probably will have with one click, you will say that you install all of this, and AWS or Azure will take care of install. So even you don't have to go and install a Hadoop or a Spark separately. All of these things automatically will be spun off in the backend. You just need to say that, okay, I want to make a machine learning studio or build a machine learning studio environment, where I'll build my machine learning model and deploy my machine learning model, and Azure or AWS will build all of these Hadoop, Spark, etc., whatever is required in the background. I don't have to even specify that I need a Spark or I need a Hadoop. Okay, so things have become very, very easy with this kind of platforms. Make sense? Any other questions? Conceptually clear? I thought I'll explain this to you because for you this is very important, because most of you, as I mentioned, most of your work, and I presume so, will be related to sensor data. Because you are
No,
not
one
an
question.
e-commerce. Yeah. Am I
One
correct?
question.
Sorry.
Yeah, sorry, Athanas.
No, no.
One question. How do you differentiate the data lake in this case?
See, data lake is an environment where you are putting all types of data. Okay. So how does an organization store data? An organization may store data, let's say, and we'll very soon go into that. Let's say something like a structured data in the form of columns and rows. Now, when you want to store a data in the form of columns and rows, the schema of the data has to be defined beforehand. You know that what are the columns, and you also know what is the approximate number of rows that you are expecting. And you build a database, a relational database management system to manage that. However, in many cases, the schema of the data is unknown. When the schema of the data is unknown, and I'll give you examples later on on that, when you don't know what is the structure of the data, you first have to dump the data into some place which can store the data even without a schema. That is a data lake. Now, I can have a data lake in a traditional format of scaling up. If the data can be stored in conventional means, or if I know that the data can be so huge that is not possible to be stored and computed in conventional means, then I will have a data lake in the format of Hadoop distributed fault, any distributed file system. So data lake is a concept where I can store, or rather an environment where I can store the data without knowing the schema. That's a data lake. Now,
Okay.
are all
Yeah.
data lakes distributed file system? No, not necessarily. A data lake can be just a conventional scaling up form of mode of data lake, or it can also be distributed file system. Okay.
Okay. Thank you. Thank you.
Great. Any other thoughts, questions? Great.
So
Now
how
we
can
are.
we,
Yeah, sorry. What? Yeah.
sorry, no, how can we correlate with our Excel file? Maybe if I'm starting, I'm working in an Excel file.
Yes.
Then it is communicating with the computing mechanism and then giving you the output.
Yes.
And then I'm able to save that file. Huh?
No. So the closest comparison you can make is, imagine a huge Excel file. I mean, it's not possible, but let's say you have 1 billion records.
Okay.
Now, can I have one Excel file with 1 billion records? No, I cannot. Right. So I have to have that Excel file in multiple machines. Okay. Then the question will come that, okay, if I have to do a computation, let's say I want to find out what is the total salary or average salary, how do I do that? Okay. I have to then, if 5 of us have parts of those data, I have to temporarily compute the salary, the average salary in each of these Excel files. And then each of these averages have to be sent to some other machine where the overall average will be computed.
Okay.
And that cannot be done in our machines, because our machines are meant for only storage, not for compute. Okay. So that's the, you can think of that analysis. So here the whole idea is it has become so huge that it's no longer possible to have it in one machine.
Okay, thanks.
Great. Okay, so the next concept again is very important, which is to understand the difference between structured data and unstructured data. Okay. And in fact, the question that you asked earlier, that what is a data lake? What is the need of a data lake, and how is data lake different from, let's say, some other form of storage that is there in the enterprise, a relational database management system? So this will make it very clear. So as I mentioned that in the age when organizations were capturing the IT data primarily. I'm right now not getting into OT. The way the OT data was stored was very different. It was kind of, you can say, strings of data, like you do it in microprocessors. Okay, so it's a very low level data. And it was okay because it was not meant for any analysis. It was just meant to, trigger, start a machine or stop a machine, that kind of thing. But the IT data required analysis. So the IT data, the data will come in the form of rows and columns. We all know that that can be something like an order ID, product ID, customer ID, or whatever, quantity, thanks, amount. So here I know when I am, before I start storing the data, I know what are the information I want to capture. Correct? Okay, typically when those of you who have been in IT know that you have the system requirement, document, and functional requirement, technical requirement. So at those stages itself, you identify all these attributes, what you want to capture. And you create a database. And when you capture the data, you will capture only these. If you want to capture something additional, you have to go and change the database and then start capturing, which obviously will be very rare because you know beforehand what each of these data consists of. Also, so this is relational database management system. This relational database management system has a very interesting property, which is called the ACID property. It stands for atomicity, consistency. Did you have any session on RDBMS? Since it's did you have any course? Okay, so
database.
Yes,
we didn't had any idea regarding database management or cloud or anything.
Okay.
It's the first time. Yeah.
Okay. So atomicity, consistency, isolation, and durability. I will not get into all of this because then it will become an RDBMS course. But one thing is very important in the context of what we are discussing here in terms of structured and unstructured data, which is atomicity. What is the atomicity property? The atom, and we'll soon understand why I'm mentioning this property. Atomicity property means that the value in each of these cells. So basically, you have these columns, which technically is called the attributes, and you have the rows, which are technically called tuples. And then you have the cell, which uniquely, and like Excel, right? In Excel, uniquely identify a cell, which is a unit of data, unit of information. So the unit of information is atomic in the sense that there will be no situation where there will be a need to break this down further. So for example, if I say that the date is 26/7/25, when you're storing the data, you are assuming that there will be no need in future to break this data further, in the sense that there will be no need where I will need to find out how many orders were placed on 26th of, on a date which is 26. Okay. Which means that if I need this information, that means the data is, I'm breaking the atomicity property of the RDBMS. Essentially, I'm saying that I need the information at a level that is lower granularity than the way it has been stored. Okay. For example, in that case, I have to store with day as a column, month as a column, and year as a column separately. Of course, can I process this in the application level? That, okay, I just extract the date of it. Yes, I can do that. But then there's an additional load on the application level. If I have to do it on a very regular basis, that's not a very good idea to do. So in a relational database management system, not only the data is in the form of rows and columns, also there is no apparent need to break down the data further. For example, if there is a customer name, and if I write Otanu as my customer name, okay. So there is, if I do it in one column, there is no apparent need of the organization to, at any situation in the future, to break this down further. That means the organization does not need to know how many customers have Atanu name. Okay, something like that. Okay, so that is the atomicity property, and that is a very, very fundamental property of relational database management system. Okay, so far fine, everybody.
So that means atomicity means data can be used without any further breaking up of the data into
there is
next
no
level.
Perceived, there is no perceived need to break down the data further at a level which is a lower granularity than a cell.
Okay. For example,
Okay.
this date, what you mentioned. So further,
Yes.
maybe this data can be used as it is without breaking. Otherwise, maybe for specific case, I need the time as well. So that cannot be atomicity.
Right. And once in a while, I may need to know the date, but if it is a very regular thing, it may not be a good idea to store it in this fashion. And there are a few other cases where things may be actually impossible. Certain information you may not. In this particular case, you may, if I want to know what is the total sales in the year 2025, you may still do an extraction at the application layer and get that information. But in certain cases, it may be nearly impossible or extremely compute intensive to do that. Okay, and we'll see such cases. But these are two fundamental properties in an RDBMS. Okay, so far fine, everybody?
Yes.
Great. Now the question is that can all the data of an organization be stored in this format? In the sense that can I always know what is the schema of the data even before I receive the data? Is it always possible? Because this assumes, RDBMS assumes I know the schema means the format of the data. Essentially, it talks about what are the attributes, like the order ID is an attribute, and what is the type of data. I may say the type of data is numeric, the type of data, product ID is, let's say, character. Okay. So this is called the schema of the data. What are the attributes of the information that I am capturing, and what is the data type? Okay. Now, is it possible to know this information always beforehand? The answer is no. The answer is no. Why? Let's take an example. Let's take a simple example of an e-commerce company. Now, let's say the e-commerce company starts by selling t-shirts, and it decides to keep the information of its products in a table, and it decides that, okay, fine, since I'm keeping t-shirts, what information do I need to capture? I probably need to capture the product ID. I need to capture the product name. And I need to capture some attributes of the product. Since it's a t-shirt, I know the attribute size, color, let's say gender maybe. Okay. And let's say, yeah, I think that's, can say colored, uncolored, whatever, but let's say this is, so I have or maybe brand also. So product name, let's say Nike t-shirt. Size is medium, color is blue, gender is male, and brand is Nike. Then the next one comes, no problem. Next t-shirt is in stock, again Puma or Polo t-shirt, female. No, red, size is large, let's say red, female, polo. Like that it goes on. Yeah, no problem. Same as RTVs. But now this e-commerce company says that, okay, fine, enough of selling t-shirts. We have sold many t-shirts. Now we want to expand our business and start selling laptops. Now, can you tell me what happens?
The schema
attributes are
itself will
different.
change.
Okay, first of all, the attributes of laptop are very different. There may be some common, like size and maybe color, okay, or brand, but there'll be many other things. Now I need to know various other things like what is the processor, okay, what is the RAM, what is the hard disk, which are absolutely not relevant for t-shirts. And there are certain things like gender, which is absolutely not relevant, or even size for that matter, which is absolutely not relevant for laptop. So now I have a problem. What is the problem? The problem is, first, when I get the laptop, first, there will be certain data which will be null. There's no need for that data. That is not relevant for laptop. And there'll be some data that will be relevant for laptop. But because it is a structured schema, I need to add these attributes. And now once I add these attributes will be applicable for all the products. That is the limitation of a tabular format. That all the columns, it assumes that all the columns are applicable for everybody. So if it is not applicable, I can write null. But this column will be there for all the rows. I cannot say that for this row, these columns are not required. Don't show me. The columns will be shown for all the rows. I may at best write null. So I have a problem. First, I have to change for any new product. There is a lot of nulls. I have to change the schema and update those products that are already existing with value null. Okay. What is the third problem? The third problem is this way I'm keeping on adding more products, more varieties of products. A time will come when the number of columns will be very huge. Maybe 20,000 columns, 30,000 columns. Because my variety of products have increased. And most of these columns will be null. Because out of these 20,000 columns, for a particular category of product, only 10 columns are relevant. Remaining are not relevant. So majority of the values will be null. This results in something called a sparse table. That means only few values are filled up, rest are black. Moment you have a sparse table, those of you coming from IT background, there's a concept of joining of tables. Multiple tables have to join. Moment you have a sparse table, the joining of tables become extremely compute intensive. It's impossible to fetch data, but by joining sparse table. So in this kind of situation, this method of storing the data in the form of columns and rows will not work. Is this clear, everybody?
Yes, clear.
So what is the other way of storing the data? Now that is where the unstructured data comes in. That means I am storing the data without any predefined schema. How will I store? So my first record will be, let's say, I will store in the format of something called key value pairs. So there's a key, let's say product ID is a key. There's a value, okay, 1, 2, 3. Brand is a key. There's a value, Nike. Then size is a key, is a value, M. Then whatever, let's say, price is a key, rupees. Now, this set of key value pair forms a record. Interestingly, when I create the second record, the keys can be different. There's no need for the keys to be same. So the second one can have product ID 456, brand, HP, and now the second one may not have size at all. The second one may have processor, i7, RAM, 8 GB. So now this record and this record, both of them have 4 attributes, but these 4 attributes are not necessarily common. Okay. So this method of storing the data is, or rather this type of data, when you store the data in this type of format, is an unstructured data. Because it doesn't have a structure. Unstructured data is stored in NoSQL databases. For example, there are many NoSQL databases. MongoDB is one of the popular NoSQL databases. Why it is called NoSQL database? Because SQL, if you know, SQL means structured query language. It helps to retrieve and query the data. So one is I input the data, that is I'm recording a transaction, but then the management also needs to query the data. What is the total sales of product 1? I need to find out how many cases product 1 has been sold, find out the total amount and add it up and say that this is the sale of product 1. Now, structured query language works when the data is in this tabular format. Now, obviously, if you have to query a data in this format, the structured query language will not work. So the database that allows the query to run, even if it is not in a structured, data is not in a structured form, that is a NoSQL database. NoSQL database has the capability to query even when the data is not structured. Up to this clear, everybody?
Sir, one doubt. This
Yeah.
key value pairs, what you explained, this data
Right.
will be in array, the array form, or it will not be in a tabular form. That I got to know that.
Yes. Yes. Now,
With
now
that, yeah.
and the array form is how internally it is going to store within the database. Okay. So internally, the data can be stored in the form of an array, or it can also be stored in the form of a matrix or various other things. Okay. But externally, the external interface, when you give this data, you have to give the keys that you want for the record and what are the respective values. It looks very similar to the way I have written. It has this second curly bracket and you put this data like this.
Understood.
But internally it can store as an array, it can store as a matrix. Okay. But we don't need to, when I'm entering the data, we don't need to do it like that. That internally the database will take care. Okay. Okay, so far, fine?
Yeah.
Yeah. Great. Now, does it mean that all data, so you may say that fine, why was the need of RDBMS then? Okay, let the entire enterprise be on unstructured data because it takes care of everything. The answer is no. The unstructured or NoSQL data has its own disadvantage. One of the major disadvantages is consistency. So I may have a second one, third record, where the product ID is 789 and the brand is somebody writes Hewlett Packard. Both are same, but the system will allow to enter both the formats of the brand, HP and Hewlett Packard. And if the management searches at how many HP laptops were sold, it will not consider Hewlett Packard because it will consider Hewlett Packard as a separate entity. In RDBMS, you can control that through something called normalization. You can either have HP or you can have Hewlett Packard, not both. By mistake. I mean, if you deliberately want to have both, that's a different thing. But by mistake, it will never happen that some products will have HP and some products will be called Hewlett Packard. So unless you need that, you have the necessity that you don't know the structure upfront, it is still better to have RDBMS. Okay. So it's not that you will go for unstructured data in all the cases. So far, fine. Now let me ask you a question. Let's say we all have seen reviews in Amazon. Okay, that means there is a product and the product has some reviews. Now these reviews are in the textual form and text form. Do you think the reviews stored in text form is structured data or unstructured data?
It is unstructured data.
Unstructured.
Okay. Why do you think is unstructured data?
Because it cannot be, because many review the characters or the length of the review may be different, and also the keywords may be different, and you cannot store it in a tabular format.
Okay. Okay, let's understand how it is stored. So you have a product ID. You have a customer ID. A customer is making a review, and you have the review. So product ID 1, customer ID 1, review says, I like the product. Product ID 1, customer ID 2, the other customer doesn't like the product. I dislike the product. This is how the data has been stored. Very much in the form of rows and columns. So why are we saying it is unstructured data?
Because the text, what we can enter, there is no specific, I would say, the length or keywords to be used. So you can type whatever you want.
That's right. Yeah, so is, for example, customer name. In the customer master database, you can always type the name as you want. Okay, so here is the very important catch or very important concept that you must know. Whether, and that's where the atomicity property, what you discussed, will come in. Whether a data is structured or unstructured depends on the use. So let's say, so first of all, actually, when we review the data, review any product in Amazon, Amazon is storing it in this format. It is very much storing in the tabular format. Because there's no reason to store in any other format. It's the schema is known. Somebody is trying to enter. Okay. So the schema is known. Product ID, customer ID, and review. That's all they want to capture. Maybe date is known. It's not that it will going to change. However, let's look at the use. If my objective is to find out, let's say, how many reviews this product ID 1 get? Can I get that information from this table?
Yes.
Because all that I have to do is to just query on the product ID, count the number of reviews. I am not breaking the atomicity property because I have no reason to break down the words in the review. I don't need that. My objective is to know how many reviews. So I don't need to break down the words. However, if I want to do what is popularly called sentiment analysis of product ID 1, that means I want to know on an overall basis, based on the various reviews given by the customers, what is the sentiment of my customers for this product ID 1? Is it positive or is it negative or is it neutral? Now, at a very basic level, what do I need to do? At a very basic level, I need to basically find out, and this is very basic level, there can be more sophisticated sentiment analysis, but at a very basic level, essentially, I'm trying to find out that how many times, let's say, the word like has been used and how many times the word dislike has been used at a very basic level. If like has been used 100 times and dislike has been used 2 times, I can say that like is a positive sentiment. I have a dictionary to tell me that like is a positive sentiment, dislike is a negative sentiment. So largely it is positive because 100 minus 2, 98 people have said like. That's all at a very basic level I'll do with a sentiment analysis. But in order to do that, I have to violate the atomicity property of this table because now I have to break down the words. The atomicity property is now violated. And when I break down the word, as you rightly said, some of you, that there is no fixed number of words or fixed number of characters. So moment I break down the word and try to store it somewhere, I cannot store these broken down words, I, like, the, product, etc. Each of these words, I cannot store in a tabular format because one review may have 10 lines, 10 words, another review may have 100 words. So I have to store in a key value pair where I say word 1 is 1, word 2 is like, word 3 is the, word 4 is product for the first record. Second record, word 1 is 1, word 2 is dislike, word 3 is the, word 4 is product, fifth can be product, dislike the product very much. So word 5 is very, word 6 is much. So I cannot store that broken down words in a structured format. So when we say that the review is unstructured data, we are assuming that we are using the review for the purpose of sentiment analysis, which will require breaking down the word, violating the atomicity property, and storing the words in an unstructured data format. So remember, whether a data is structured or unstructured depends on the use. Make sense so far? Clear? Any thoughts, questions? All good?
Yes.
Yes. Yes. Sir.
Yes. Okay. So let me give you another example. In Amazon, I go to a product page and I find the picture of a shoe. And there's this shoe, and there's this add to cart button, etc. Now, this picture is it structured data or unstructured data?
You are trying to add a shoe, picture of a shoe into the.
No. I'm going to Amazon to buy a shoe. I search for shoes. I got this. Yeah, and I went to the what is called the product detail page. That means the page where I have the picture, I have the price, everything, and then there's the add to cart button, and I click on this add to cart button and proceed to purchase. So this picture of shoe that I see here, is it a structured data or unstructured data?
Structured.
Image of shoe. Structured. Why do you say so?
As you just mentioned, based on the usage.
Right.
So the particular e-commerce retailer has put that shoe as a picture for which he can further go and then go to the details and order. So it is a structured data stored where you can go to that particular shoe brand and then go to the next.
Right. So what happens is that the way it has been stored, product ID, product name, etc., and price, and along with that there is an image, and in this image typically you will have, so image is a, let's say, a JPEG file. So image will have a link. This image column will have a link that will point to the location of the JPEG file. So when we are going to Amazon, what is doing, I'm clicking on a particular product, so it's checking the product ID. From the database, is getting the name, it is getting the price, it is also getting the link where the image will be stored. And from that link, it is fetching that link and showing the image to me. So there is nothing unstructured about it. Everything is structured. But then why do people say that images are unstructured data? No, text, image, sound, these are all unstructured data. Why do people say that?
If we want to search an image with an image as an input, then
Very
it will become an unstructured
absolutely. So if the situation was, and many e-commerce sites are providing that facility now, that see, I have seen my friend wearing a very nice shoe and I want to buy exactly that shoe. So what do? I take an image of the shoe my friend is wearing. I upload the image in the e-commerce site and tell the e-commerce site, find me a shoe that is similar to the image that I've just uploaded. I don't know which specific brand, which specific color, you figured that out. That use case will be an unstructured data. Why? Because in that situation, how is the system doing it? You have the shoe, it is breaking down into small pixels. Atomicity property is broken. It's breaking down the shoe into small pixels, just like here we broke down into small words, into each word. Here is breaking down to each pixel and is trying to match each and every pixel with the pixel of other shoes available in the store. And when the pixel matches up to a certain degree, it says that this shoe looks similar to this shoe, and hence, this is the shoe that you are referring to, and buy this shoe. So because I am breaking down the image, I need to break down the image, or the e-commerce company needs to break down the image. This particular use case is the use case of an unstructured data. So next time when anybody says that, can you tell me whether this data is unstructured or structured? It all depends on the use. So if I'm using computer vision to find out the defects on my line, that is an unstructured data, because essentially I'm taking a picture of a product in the line, comparing it with a good product, and let's say seeing that there's a crack and rejecting that product. Okay. So far, fine, everybody?
Yes, sir, clear.
Great. Now, the last thing before we close for today, if I ask you, is big data structured data or unstructured data?
Can be both.
Can be both. Very good. Absolutely. So this is another very popular misconception that big data is unstructured data. No, big data and the data being big or small and the data being structured or unstructured are two independent dimensions. You can say like this, these are two independent dimensions. On one dimension, I have big and small. I mean, nothing really called small, but to differentiate it from big, I'm just calling it small. Okay. And on the other side, you have structured and unstructured. So when I am using, let's say, sensor data for predicting machine failure, we are talking about big data because a huge amount of data which can be stored and computed only in unconventional methods, scaling out, but it's structured data. There's nothing unstructured. I know the ID of the device. I know what I'm capturing, temperature, humidity, vibration, etc., etc. There's nothing unknown about it. And all of them are atomic data and keep it like that. Okay. So it is big data, but structured data. But let's say I'm using computer vision to detect factory intrusion. Has somebody gone inside a secured zone? Huge amount of data coming in because I have a CCTV camera streaming data coming in all the time, and I cannot store it in conventional means. If I want to find out an anomaly that the person who is entered is not the person who usually comes, I can detect it from various ways, from different the nature of the movement and even face recognition. But sometimes the face recognition may not always. So let's say I want to find out even within a bona fide person is trying to steal something. Okay, their face recognition will not work because the person is bona fide. So I have to look at other movements, what the person is supposed to, not supposed to, the person is doing. So definitely unstructured big data. Okay. If I have something like, sentiment analysis for a specific movie, okay. If it's for entire, let's say for Netflix, it will again be big and unstructured because Netflix will have so many reviews. Let's say for a specific movie I want to do, then the data is unstructured, probably the data is not that big. And usually most of our transactional data, sales, purchase, accounts, these are all small structured data. So this is kind of a 2x2 matrix. These are two independent dimensions, you can say. Make sense?
Yes.
Great. Okay, so I think we'll close for today, and this both yesterday's and today's this thing I'll upload it in Teams. Okay. So
Sir, it will
this
be
was
helpful if you able to upload these notes what you have written also.
Yeah. Of course. I meant that also because this is not there in the standard PPT because it is not, I mean, technically a part of predictive analytics, but I thought that I should give you this background so that it's relevant for your kind of business, because it may not be relevant for other types of business, but it's relevant for your type of business. So that's why. Okay. And so from the next week, we will get into the actual predictive analytics. Okay.
Sir, there's also one question in the chat from Hemant.
Was there a question? Okay, 1 second.
Instead of 2 assignments, can we have a quiz, which is basically the structure for all the other
See, I would recommend you do the assignment because the assignment is the one that gives you the hands-on exposure. See, the problem is that the method of administering examination, which is a pen and paper type, and that too, there's a very weird way that you have to go to an exam center, write on pen and paper, then take picture and then upload. The very, very cumbersome method, I feel. And more importantly, this kind of subjects, the pen and paper examination is hardly relevant because this has to do with the way you work. Okay. And the only way I can assess your ability to build models is through a hands-on exercise. Okay. So let us keep that. I think it will be a good learning experience for you because pen and paper examinations are, these are very archaic mode of evaluating. Okay. So yeah. Great. So then I'll see you next week. Okay. Bye everybody. Bye.
Thank you. Bye.
Bye.
Thank you.
Bye.
Thank you. Thank you, sir.
Thank you, sir.
Bye.
Thank you. Thank you, sir. Bye.
Thank you. Bye.